Okay, so let's look at the numbers here. Whenever we're talking about systems and momentum, we have to define a coordinate system so that we know which velocities and momenta are positive, which momenta are negative. And so let's go over here and take this direction to be the positive direction. So that means that the original momentum of the 3 kilogram ball is going to be in the positive direction. The original momentum of the 5 kilogram ball is going to be in the negative direction. So we have to take that into account when we write down the total momentum of the system. So let's do that. So for part A, the total momentum of the system, this is a vector quantity, is going to be equal to the momentum of the 3 kilogram ball plus the momentum of the 5 kilogram ball. And so that's going to be equal to, so we've got 3 kilograms times the speed of 4 meters per second. And I should probably put in units here. So this is 3 kilograms, 4 meters per second. That's a positive velocity. And then I have to add the momentum of the 5 kilogram object. So it's 5 kilograms. Now, since it's moving to the left, its velocity is negative. So that's minus 4 meters per second. And so adding these all together, I get that the total momentum to the system is equal to minus 8 kilogram meters per second along the direction that we've specified. Now, if we really wanted to be fancy, we could go in here and put in I-hats for the unit vectors and say that this is minus 8 kilogram meters per second in the I-hat direction and make this a full vector. So that's one way of writing it down. OK, so that is the total momentum of the system. We know that during the collision, this doesn't change. And so we can, for part B then, we can write that the total momentum, again, we started with P3 plus P5. That's the initial one. At the end, these two things stick together. So the total momentum, now I have the mass of the 3 kilogram system plus the mass of the 5 kilogram ball, I guess, times the final velocity. They have a common final velocity because they've stuck together. So the total momentum at the end is the sum of the masses times whatever that velocity is. This quantity, the sum of the masses times that final velocity, has to equal minus 8 kilogram meters per second because that is the total momentum of the system. That doesn't change. And so the sum of the masses is 3 plus 5 equals 8. So this is 8 kilograms times V final. So since my momentum is minus 8 meters per second, kilogram meters per second, in the I-hat direction, then if I divide through by 8, I get that velocity final is equal to minus 1 meters per second in the I direction. And so what happens when they stick, these two things are moving at the same speed. So clearly the object, the 5 kilogram object, has more momentum. So when they stick together, the system is going to be moving in this direction slowly. And so that is what these equations tell us. If we just look at this picture of these two things moving at the same speed and imagine them sticking together, you can see that since this one carries more momentum, then the whole system will end up moving to the left once they stick together.